Good morning, Kelsey. Morning, Madison. Hope y'all are doing well. I'm just going to go through the review and just kind of want to remind you all that I cannot see if y'all are texting questions. So if one of you is not too shy to use the mic and let me know if somebody types a question, I will toggle back and forth just to make sure everybody's understanding. But I'm just going to go through the whole review question by question. I kind of timed myself doing it a little earlier, and I was able to do it in about 30 to 35 minutes. So, and I also want to point out to you guys that I kind of looked over the test, and obviously the test is exactly like the review. It's going to go in the same order, same number of questions, all of that. There's one question on the review that I would definitely say is harder than anything on the test. So if you can conquer that on the review, you guys should, and be able to conquer everything else on the review, you guys should be good to go for the test. So we'll just start at number 1 and work our way through. Hey, Adriana.
Hi.
How are you?
Good. How are you?
Good. Thank you for coming.
Yeah, no problem.
We have a couple of other people, but they have their mics off. So if somebody asks a question or asks me to stop, would you mind just hollering at me and letting me know?
Yeah, sure.
Thank you. I was just telling them that the review is exactly like the test. I've already, taken a look at the test. There is one question, and it's actually in the geometric series where we get the sum. The one on the review is harder than anything on the test. So if you can conquer that one, everybody should be good to go on the test tomorrow.
Okay. And
the whole review took me about 35 minutes when I was just working it straightforward without obviously explaining it. So
okay.
I don't think the test is going to be too bad. I think you guys are going to do great. But we're just going to start with number 1 and work our way forward. Determine if the sequence is arithmetic. If it is, find the common difference. So the formula for finding the difference is just taking the second number, A2, and subtracting A1 from it. So in this case, we'll take 49 and subtract 29, and that will give us 20. So the difference is 20. Doing the same thing on number 2, we'll take the second number, 167, and subtract the first from it. Little bit of a difference there is we're taking 167 minus a minus 33. So that actually changes to a plus, and our common difference is 200. So both number 1 and number 2 are arithmetic, and we can find the common differences. Number 3, the instructions are find the 3 terms in the sequence after the last one given. So the best thing to do on these is to go ahead and once again find your common difference in order to ensure that you're going to be handling everything correctly. So you'll take the second term, negative 24, and subtract a minus 30, which once again, that gives us a minus minus. That turns that to a plus. So negative 24 plus 30 equals 6. So our common difference is 6. So we're going to add 6 to negative 12, which would give us a negative 6. Then we'll add 6 to negative 6, which will give us 0. Add 6 to 0, and then that will give us a 6. So the next three terms are -6, 0, and 6. On number 4, once again, start by finding the common difference by taking the second term and subtracting the first term from it. And that would give us a -21 plus 26, which gives us a common difference of 5. So we will add 5 to -11. That will give us -6. We'll add 5 to -6, and that will give us a -1. We'll add 5 to -1, and that will give us 4. On number 5, we're asked to find the formula. Once again, with an arithmetic series or sequence, it's just best to find the common difference, which is going to be 41, taking that second number in the sequence and subtracting the first from it, and we get a common difference of 4. Then the formula for the generic formula for an arithmetic sequence is a sub n with the first term plus the difference times n minus 1. So we'll use this generic formula to fill in what we know to get the explicit formula. So a sub n, what's our first number in this sequence? 37. Then we will add our common difference, which is which is 4, and multiply that by n minus 1. Now you can't stop there. You have to go ahead and distribute this 4. So you would have a sub n 37 plus 4n minus 4. And now I'll combine like terms. That's the 37 minus 4 gives me a 33 plus 4n. And that is the explicit formula for number 5. Are there any questions so far?
No, ma'am.
Okay. I'm going to go ahead and rewrite the answer right here and give myself some space down below. Oh, good. I just wrote right over my instructions. Find the formula and then find the listed term. Okay, so once again, best place to start on an arithmetic sequence is finding the difference. So we'll take that second term and subtract the first term from it. So 20 minus 13 is 7. And so we'll go ahead and use this generic formula over here and plug in what we know. A sub n equals, and then our first term is 13, plus our difference, which is 7, and then n minus 1. We'll distribute our 7 to give us 7n minus 7. 13 minus 7 is 6 plus 7n. So our explicit formula is 6 plus 7n. Then you'll plug in the number 24 in for n to find a sub 24 is 6 plus 7 times 24. And 7 times 24. I have a full answer of 174 for that. I've already worked that out. I'm assuming everybody could do that part on their calculator. Is that correct?
Yes, ma'am.
Okay. Did everybody get 174, or were y'all just working with me?
I think everyone was just working with you.
Okay. All right. Thank you, Adriana.
No problem.
All right. Any questions so far? Are y'all feeling confident about this?
Yes, ma'am.
All right. Good. I'm so glad. Okay, arithmetic series. The first thing that I'm going to do is rewrite the formula for you guys just to remind you of what it is, and then I'll start with the problem. And the reason why I'm doing this, and I don't want this to confuse anyone. So we've been going through this, and the book has the formula written like this, where you've got the number of terms out front, and then you've got A1, or the value of A1, plus the value of the last term, all divided. That's supposed to be an L, by the way, for last, all divided by 2. The video that I know that I showed, and I think Miss Stone showed the same one, showed the formula like this. Either way is fine. At some point, you're going to be dividing something by 2. That's the thing to remember. A lot of times, what I do to shortcut is if my terms are even, I divide this part by 2, just because it's even. If it's odd, then I use this formula.
Are the formulas going to be given to us for the test, or do we have to memorize them?
I'm planning on giving them to them, and I think Miss Stone as well. Just the blue sheets that we handed out the other day, and then we will be putting on the whiteboard the additional 2 that we learned, the recursive and the infinite sum.
Okay.
But I just wanted to make sure everybody kind of understood how I'm going to be working these next couple. Because like I say, this first number 7, the number of terms is even. So I typically just go ahead and divide the number of terms by 2. But I can be consistent if that's going to mess anyone up. Anybody have any preferences?
No one's saying anything, so I guess not.
Okay. So I'll just take the number of terms, which in this case, because both my top term and my bottom term, goes from 1 to 6. Then it would be 6 divided by 2, and the value of A1. How do I find the value of A1? I plug in 1 for I, so that would give me, for 6 times 1 is 6, minus 13 is -7. How do I find the value for the 6th term? I would plug in 6 for the I, which would give me 36, minus 13, which is 23. Correct? If I'm doing my math right.
Yes, ma'am.
Plus 23. So 6 divided by 2 is 3. -7 plus 23 is 16. And my final answer is 48. Any questions about that?
Where did the 2 come from?
The 2 came from the original formula. Like I said, good question though. And that's why I was asking, is if there is a preference about formula.
Oh, okay.
You can either do it this way, which is the number of terms divided by 2 times the value inside, or you can use this formula, which is the number of terms times the value of the first term and the last term divided by 2.
Okay.
But there is a 2 in the formula somewhere.
Okay.
Does that make sense?
Yes, ma'am.
And so you would just plug in. So basically what I've done then, if you're looking at the formula down here, I've plugged in the number of terms here, which was 6. And then I plugged in the value of the first number in the sequence, which was -7, the value of the last number in the sequence, which was 23. And then I combined those, -7 plus 23 for 16, and then multiplied 3 and got my 48.
Okay.
But there are a couple of ways to approach this. And like I say, the video that we showed approached it one way. And then I believe that the book is actually the formula that's left up on the screen. And so I'll probably use that particular formula for this next one. I'm going to so on this one, I've got 7 times, and then I'm going to put my 2 here, which is this formula down here, okay? And the number of terms that I have is 7. And now I want to find the value of the first number. And I do that by plugging 1 in for n. So 2 times 1 is 2, plus 3 is 5. And then to find the value of the last term that they're asking me to find the sum for, I'll plug in the 7 times 2, which is 14, plus 3 is 17. So 5 plus 17 is 22. Divided by 2 is 11. So my sum is 77.
I have a question.
Yes, ma'am.
So for the formula, it's A1 plus AL?
Yes, ma'am.
Oh, okay. I thought it was minus AL, so I've been getting like all of this wrong. I got it now.
Okay. And I can understand where that might be a little confusing because in the geometric series, we do 1 minus the ratio raised to the power of the terms. So, you know, that could get a little confusing. So I'm glad we had an opportunity to clarify it. Because basically, when you're thinking of arithmetic, I guess the best thing to do is to think more about adding and finding the average.
Okay.
You know, because when you add 2 things and you divide by 2, you're finding the average.
Okay.
So I don't know if that makes a good connection for you or not. For that. But yeah. And once again, I think being able to look at the formulas while you're doing them and just confirming. And I will tell you, you know, it is a little bit of extra work, and I understand that. But oftentimes when I'm actually doing them on my own personal paper, I go ahead and almost write down the formula every single time, just so that I kind of get into a rote habit of making sure that I do the right arithmetic step, you know, whether that's multiplying or whatever, because when you're working with all of these different types of series, the similarities and differences, you know, are sometimes can be I don't know, maybe get a little confusing, fuzzy. So just make sure that you're applying the right formula.
Okay.
All right, now we're actually starting on the geometric series on number 9. So what you're going to do to find the common ratio, different than finding the common difference, this time you're going to take the second term and divide the first term. Instead of subtracting, you're going to divide. So in this particular case, that common ratio is -6. So R would equal negative 6. Number 10, you take the second term, which is 10, divide it by the first. The common ratio is 5. On numbers 11 and 12, find the 3 terms in the sequence after the last one given. So what you're going to want to do is find the common ratio by dividing the second term by the first. That gives us a negative 6. And then you'll multiply that negative 6 by the last term, which in this case is negative 216. And negative 216 times negative 6 is a positive 1,296. 1,296 times a negative 6 is a negative 7776. Sorry about that messy writing. And then a negative 7776 times negative 6 is a positive 46,656. So those are the next 3 terms for number 11. Number 12, negative 16, which is the second term, divided by the first term is negative 4. So then you'll take that negative 4 and multiply it by the last term, which in this case is a negative 256, which that would give you a positive 1,024. Then you multiply that by a negative 4, and you get a negative 4,096. And then you multiply negative 4,096 by a negative 4, and you get a positive 16,384. So those are the next 3 terms for both number 11 and 12. Number 13 and 14, find the formula. To find the formula, and this gets, I just want to point out, this is one of those situations where the formula is really, really important. It's so much easier to find the formula for a geometric sequence than it is an arithmetic, because there's not any combining that goes on. The first thing that you want to do is find the ratio, which is in this case is going to be the second term, negative 24, divided by the first term, which is negative 4, which gives you a positive 6. So the formula for this arithmetic sequence is a sub n. Then you take the first term, which is negative 4, times the common ratio, which is 6, raised to n minus 1, and you're done. That's it. You don't do anything else. You don't combine anything. You don't multiply the negative 4 and 6. You're done. It's just simply the first term times the common ratio raised to n minus 1. That's all it is. So for number 14, and I don't think there's any that this, I mean, I know now we're dealing with decimals. You could actually take the third term and divided it by the second term in this case if you wanted to. But negative 3 divided by a negative 1.5 is 2. So my common ratio for number 14 is 2. So to find the formula, you plug in what we know, a sub n times the first term, which is negative 1.5, times the common ratio, which is 2, raised to n minus 1, and you're done. So the first term times the common ratio raised to n minus 1. You don't combine anything. Just leave it like that. So the answer to number 13, the answer to number 14. Find the term named in the problem. Okay, so we have to find our common ratio. It's not even asking us for the explicit formula. So we just find our common ratio, which is negative 4 divided by 1. So our common ratio is negative 4. Our formula for a geometric series is a sub n. And the sub What was our common ratio? -4. And then that -4 is raised to n minus 1. What is n in this case? 9. So what is n minus 1? 8. So to find n sub 9, you take the first term, multiply it by the common ratio raised to n minus 1, which is 8 in this case. So this number is 65,536. Because a negative number, and let me also caution you guys, when raising a negative number to a power in your calculator, make sure that you enter it just like this. The open parentheses, -4, close parentheses, raised to the power. Because if you do not include the parentheses, it thinks that you're asking for the opposite of whatever the number is. So make sure that you enter it that way. Are y'all pretty familiar with that?
I have a question though.
Yes, ma'am.
So say like if the numbers were different, if there wasn't a 1 there, would you multiply the two parentheses together first, or would you do the exponent first?
Excellent question. And you would definitely do the exponent first.
Okay.
But excellent question. So perhaps like say this series started with the number 2 as opposed to 1. You would have found the 65,536 first and then multiplied it by 2.
Okay.
Great question. Okay. I'm just telling you, this is the next number 16 is the hardest one on the review. So please stick with me. It doesn't bother me. It's fractions. And some of you might say, oh, could we just please change that to a decimal? And perhaps you could. I didn't work it with a decimal. I did do my final answer in a decimal. I did it in a fraction and then converted it to a decimal just to see if anybody else does it in a decimal, if it came close. But I'm going to do it using a fraction. So hang on. All right. With a geometric series, the first number in the formula is always the first number in the series. And the second number that is raised to the n minus 1, or in this case, the I minus 1, is always the common ratio. So in this particular case, there is no, the first term is 1 because there isn't one given. I'm going to go ahead for the sake of, just so that you all know, that the formula is the first is A1 times 1 minus R raised to the n over 1 minus R. That's the formula for a summation. So just for the sake of consistency, I'm going to go ahead and write the 1 for my A1. Then in parentheses, I'm going to put 1 minus, what's my common ratio? 1/3. And I always put my ratio in parentheses just to make a habit. And it's going to be raised to 7. And I got the 7 from the number of terms. All over 1 minus 1/3. Okay. So 1 minus 1/3 raised to the 7th power is actually 1 over 2,187. And 1 minus 1/3 is 2/3. One minus 2,187. Basically, what I would do is I would take 2,187 over 2,187 because that's the equivalent of 1. And subtract 1 over 2,187. So that's going to give me 2,186 over 2,187, all divided by 2/3. And then what that looks like is 2186 over 2187 times 3/2. Because you keep this one, you change it to multiplication, and you flip this term to its reciprocal. So this goes into this 1,093 times. And this actually cancels with that and makes it 729. So my summation for this is 1,093 over 729. There is not one like that on the test, but this is a wonderful exercise in working with fractions, which obviously you get a good bit of that in your infinite series too. Y'all are completely silent. Was that really bad? Is anybody trying it with 0.33333?
Haha, no.
No?
No.
Okay.
Fractions are easier in my opinion.
See, I think so too. I love someone who's come to the fraction side with me. All right, can I erase this or are y'all still writing?
No one said anything,
No
so I
one
guess
said
go
anything?
for it.
Okay. I didn't know if I scared someone away.
Y'all can type when she asks questions, just so I know and I can tell her. Just
Yeah, I was going to say, yeah, please type. And if they don't want me to erase, stop me. I am going to go ahead and write the final answer here once again. Which I did that via, and it's 1.499 something. But when I divided my final answer, I just didn't know. I like fractions better too, especially when dealing with these series, because you have to deal like the infinite series, you're dealing with more of them. I love that. It's not erasing well for me today. I wrote it on the wrong one. It really isn't erasing anymore for me. Is this clearer for everybody why I try to mess with my trying to erase this? Technology. I don't know. The program isn't working for me now. Are you all still there? Is it just Cami? Is everybody still here?
I'm here.
Yes, ma'am.
Okay. So it's just obviously Cami.
Maybe if you reload the page, it'll like pick up and stop lagging.
Okay, I'll try that.
It might not. I don't know, but
No, I'll try anything at this point. And I'm also trying to see if I have anything on the end of my stylus that's causing a problem for it not to, not to work. All right, I'm going to try. Not fun when technology doesn't work. Remember factoring trinomials?
Ew.
sadly.
Thank you for your patience, guys. Let's see if I think it worked. Did everybody, should I rewrite that answer? I think it collapsed on the fraction too. That was the final answer for that one. Okay. This one, number 17, is a little more user-friendly. But once again, unfortunately, we don't have a first term. So normally the first term, like I say, goes right there, but I'm going to, for the sake of consistency, go ahead and put a 1 there to remind you that typically you would be multiplying by something. Like you can see in these infinite geometric series down here, same formula premise. There's 2 numbers. The first number, which is a -2. The second number here, which is a -1/4. The first number is the first number in the series, and the second number is the ratio, common ratio. So the first number here happens to be a 1 because there's nothing there. And then in parentheses, you would put 1 minus, and then the common ratio, which is 3, raised to the number in the series, which here is 9, divided by 1 minus 3. And then 1 raised to the 9th power, 1 minus, actually, I'm sorry, let me restate that. 1 minus 3 raised to the 9th power is -19682 divided by -2. But because that's 1 minus 3. So then that turns out to be 1 times the answer to that, which turns out to be 9,841. All right. I would like to do a different problem in a summation on a separate sheet of paper just to emphasize something else instead of going straight on to number 18. So if y'all would bear with me, but I think this will help you on the test. Okay, so if you had a problem like this, the summation is the first term times 1 minus -4 raised to the 8th power all over 1 minus a -4. And I do this to remind you guys that when you see all of these negatives, it's of utmost importance to put it in parentheses and then deal with PEMDAS the way we know how. So in this case, we're going to handle the inside of the parentheses first. And within the inside of the parentheses, can everybody see this okay, by the way? Is it flashing when I'm talking?
No, ma'am.
Okay.
Great.
Okay. Everybody, okay. Inside the parentheses, you're going to raise that -4 to the 8th power. And when you're typing something like that in your calculator, once again, I want to remind you to definitely put it in parentheses. So then you would get this part. You would get to here. Okay. And then 1 minus a -4 is actually 5. So then you have 1 minus the 65, 536, which gives you a -65, 535 divided by 5. Which is -13,107 times 2 is going to be -26,214. And I showed you that because all of the examples within the study guide did not have that second number, plus there wasn't a negative to deal with. And I just want to make sure that you all know to put that in parentheses and to deal with the exponent first and all of that. Does that make sense to everybody? Yeah, it was not on the review, but I do feel like that will be very important for you on the test.
Yes, ma'am. It makes sense.
Okay. I just want to, the other thing I want to point out, one other thing, just for syntax purposes, because these things, and I know I went over this in my class, but I want to make sure I cover it in Math Lab to make sure that Miss Stone's class gets reminded of this, because I'm sure she went over it as well. But I just want to make sure that y'all are reminded when you have a problem that looks like this. Believe it or not, there's two numbers here. The first number is a -1, and the second number is a 4 raised to n-1. That's how that is read. It is very different than if you had this. Those are two different things. Do you see that?
Yes,
This goes with this, and this one actually looks like this. So you would be raising the -4 to the 8th power, and here you would be raising the 4 to the 8th power. Are there any questions about that? That's very, very important. It will change your answer.
No, ma'am. No questions.
No questions. All right, then I'm just going to keep going with the review. Okay, getting ready to start with the infinite geometric series. So a different formula. Pray that my eraser is going out on me again. Please, like, okay. I just need the technology to work. Okay. So for an infinite geometric series, the formula changes and you have your A1 term, which in this case is 64, and it's divided by 1 minus, please. Not going to write for me. I don't want to have to reload it again. It's not writing. Ugh. It won't even write with my finger either. I'm so sorry, guys. I hope y'all are praying. Yay. I guess I'll just have to keep reloading it. Minus 1/2. So once again, because we had that pause there, the summation is the first term, which is 64, divided by 1 minus the ratio. So that's going to give me 64 over 1/2, which is the same as 64 times 2, which equals 128. So the sum for number 18 is 128. Because 64 divided by 1/2 is the same as multiplying by 2. And that is my dog snoring in the background. Sorry about that. So between the poor technology and my dog snoring, math lab is pretty exciting. All right. We only have a few more. We just need it to work that long. Okay. Number 19. The first term, which is -2, divided by 1 minus a minus 1/4, which is going to be the same as -2 all over 1 plus 1/4. So 1 is the same as 4 over 4, and 4 over 4 plus 1/4 is 5 over 4. And -2 divided by 5/4 is the same as -2 times 4/5. So my answer to this one is -8 over 5. So 19 is -8 over 5. Any questions?
No, ma'am.
All right, number 20. For number 20, the formula is not given. So we do have the first term. So that's good. But we need to find the common ratio. And we do that by taking the second term, which is -2/3 all over 2, which is the same as -2/3 times 1/2, which is going to be -2 over 6 which is the same as negative 1/3. So my ratio for number 20 is going to be negative 1/3. Had anybody worked ahead and gotten that one by chance?
I don't think so.
Okay. All right, so my summation is taking the first term, which in this case is 2, and dividing it by 1 minus a minus 1/3, which is going to be the same as 2 divided by 3 over 3 plus 1/3, which is going to be 4/3, which is the same as 2 over 1 times 3/4, which is 6/4, which then reduces to 3/2. So the sum for number 20 is 3/2. Is everybody understanding how to get the ratio?
Yes, ma'am, I think so.
Okay.
No one's typing anything, so I'm not sure.
Okay. Thank you, Adriana. I appreciate your help. Okay, the common ratio for number 21, you find that by taking the second term and dividing it by the first. So that's pretty easy because 1/2 divided by 1 is just going to be 1. So that common ratio is pretty easy. So the summation will be the first term, which is 1, divided by 1 minus the common ratio, which is 1/2. So 1 divided by 1/2, because 1 minus 1/2 is 1/2. That's the equivalent. Dividing by 1/2 is the equivalent of multiplying by 2. So 1 times 2 is 2. So the answer to number 21 is 2. All right, on to the recursive. The recursive, for the arithmetic recursive, you just find the common difference and then write the recursive formula, which it is slightly different, but you would take the second term and subtract the first term. So that's going to give us a negative 10. The recursive formula is based on the term before, like, so if I've got a sub n, you're going to have a sub n minus 1, then minus, plus or minus your difference. So in this case, it's negative 10. So that's your recursive formula for number 22. It's a sub n equals a sub n minus 1 minus 10. And then that's it. Your next 3 terms, you're just going to subtract 10 from the one prior to it. So you've got negative 32, negative 42, and negative 52 for number 22. For number 23, to find the common difference, you take 27 and subtract 24, which gives you 3. The recursive formula is a sub n equals a sub n minus 1 plus 3. And to find the next 3 terms, you just add 3 to 33, which would give you 36. Add 3 to 36, which gives you 39. Add 3 to 39, which gives you 42. So to find the common ratio, recursive formula in the next three terms in the sequence given for number 24, you would take the second term, divide it by the first, which gives you a -3. And so the recursive formula for a geometric sequence is a sub n equals a sub n minus 1 times -3. So then to find the next three terms, you would simply multiply the last term, which in this case is 81, times -3. That would give you a -243. Then you multiply a -3 times a -243, and it would give you a positive 729. And then multiply a positive 729 times a -3, and you would get a -2,187. So those are the next three terms for that one.
Wait, why do you multiply that one, 24, and in the other formula you added in 22?
Good question. For these, for the number 22 and 23, those are arithmetic. 22 and 23 are arithmetic, and it says find the common difference. So you would subtract in order to find the difference. So it's kind of telling you how to do it. So this one says find the common ratio, which indicates to me that I'm going to go ahead and divide, which is really, really good. But if you didn't, if you didn't have those instructions, you try and look at the sequence or series and find out if it's kind of going up, you know, exponentially, or if it's just going up, traveling up slightly, which number 22 and 23, they're kind of just eking up little by little. But in 24 and 25, you can kind of see that they're growing more exponentially, but also the instructions do help kind of guide you as to whether you're going to be subtracting the second term from the first, or if you're going to be dividing that second term from the first. Does that help?
Yes, ma'am.
Okay, good. Okay, so for number 25, finding the common ratio, we're going to take that second term and divide it by the first, which is going to give us a +3. So our recursive formula will be a sub n equals a sub n minus 1 times a +3. So then I'll take that +3 and multiply my last, to find the next three terms, I'll multiply that last term by 3, which 3 times -54 is -162. -162 times a +3 is -486. And a -486 times a +3 is a -1,458. So those are my next three terms for number 25. Kind of all jumbled up down there. Sorry about that. I can go ahead and raise up this. Their answers might look a little prettier than mine, especially down here. They kind of got jumbled. So there is the answer key. And we had an opportunity to go through those, plus see some additional differences, just to kind of make sure I'm showing you guys how how the problems might be worded on the test, or that you might be able to see on the test. Are there any questions over the review?
No, ma'am, I don't see any.
Okay. Did everybody get the answers?
No responses? I'm assuming yes.
Okay. Oh, not yet? All right. Walker, can you see them okay? Or do I need to raise the screen up a little? Okay. I'll just inch it up. It looked kind of weird on my side. Also, for those of you, okay, Caleb. The other thing I want to tell you is what I will do is there is a YouTube link to the entire math lab because it did get recorded. And I will post that in Google Classroom. So if you know of other students, particularly juniors who had chemistry lab, or if you have other friends who were in Latin this morning, please kind of spread the word among your friends that they can go back and watch each one done if they need to see something done. And also, please know that you can email Miss Stone or I with questions. Adriana, I really appreciate your help this morning.
Yeah, of course. Cool. I'm gonna go. So
Okay. Thank you.
Yeah, of course. Thank you.
Y'all have a blessed day.
You too.
Madison, do you have any other questions?
No, ma'am.
Okay. Did you get everything you need?
Yes, ma'am.
Okay. Good deal. Email me if you need me.
Okay, sounds good. Bye.
All right. Bye-bye.